Greetings of the day, everyone. I, Aditya Gangane, welcome you all for the 4 weeks STTP on pedagogical methods for outcome-based education. My session is scheduled on 28/11/25, that is today, session number 3, and I have opted for the topic scaffolding as a teaching method in engineering. So, talking about scaffolding, basically scaffolding is a very technical term and a common term in civil engineering or construction industry. Scaffolding is a temporary structure, a support structure which has been used for a construction site. That is, if you are working on a height, then a temporary structure of bamboo or steel rods is developed, which can be seen in this image, the upper image, which can be used for the construction, maintenance and repair work. The funda here is that it is been used as a temporary structure to construct repair of a permanent structure. It provides a stable platform for the workers, people to store the work, to do their work, store the material and so on. In the same way, we as a teacher use this scaffolding teaching method to create a permanent effect on our student by giving them a temporary support while delivering the lecture or say the practical sessions also, so that it will be creating a permanent effect, that is permanent learning of our students. So basically, what is instructional scaffolding? It is a temporary adjustable support what we provide, that is the teacher provide to the learners so that he can do his studies or that targeted lecture. So you can see in the image the teacher is there and there are various students standing on the ground and some of them are on the stairs. They are willing to do their work of winning the stars and planets, and the teacher is teaching them how to climb and move towards their goal. It is very interesting, and if you observe the image, we can see some students are on ground, some are climbing and so on, but the teacher is one who is guiding each and every student as per his or her requirement, that is his or her learning capacity and understanding. So scaffolding teaching methodology needs to have understanding about students level, students understanding gaining capacity and understanding capacity. So why scaffolding matters in engineering? We are the teachers of engineering, and engineering education is one of the most complex education on earth. Higher education students like our engineering students face complex abstract theories, real world applications. So scaffolding helps us to bridge the gap between this theoretical basic knowledge of the basic fundamental knowledge what they learn during their prior education, and we teach them new concepts, and we want that they should use these learnings concepts and create something new which will be solving the real world problem. So what we are doing in engineering, basically we are developing their mindset, their skills, but from where? From various levels what the student are having, the level of their understanding. This is the exact place where scaffolding comes into consideration, that is where scaffolding teaching methodology can be used, as it provides structure and step-by-step support to bridge the students' current knowledge to new concepts, so that they will be using their earlier knowledge to develop the future knowledge and do their future works. Later, it breaks the complex engineering tasks into manageable parts. It breaks the concept step by step, block by block, so that they will be using it as required. Further, it reduces the confusion, anxiety of doing their work or completing the assignments, solving the numerical, or drafting a program or doing a practical. It encourages active learning. It is not a typical one-way action, as we are all known that now the teaching and learning process cannot be one way, or it should be two-way communication. It should be given by the instructor, teacher, and it should be wholeheartedly accepted, received, actively received, processed by the students, and he should or she should also be reverting back. This is achieved by scaffolding teaching. It improves retention, students' retention in the class, skill development, and prepares the student for real world applications and challenges. It support diverse learners by adapting to varying abilities and backgrounds. Wherever the student be or whatever the capacity of the student be, out of 60 students, each and every student has different learning, different background, different thought process, different learning capacity, understanding capacity. All these learning capacities can be groomed, can be developed and brought up to the standard required for that session or for that activity. It helps to clarify the expectations using examples, resources, and timely feedback. Here, the faculty can give the examples, the resources required for the learning, and timely feedback can be given. It improves conceptual clarity, problem solving, and reduces the subject of fears. Talking about civil engineering fraternity, the students are many a times having difficulties in solving numericals related to structural engineering or contour mapping or surveying. So all these, whatever the fears they have, they can be reduced by using scaffolding very well in the sessions. So what are the problems? Before adapting, I would like everyone of us to know that what are the present day challenges in engineering education in Indian subcontinent, especially for the students in rural and semi-urban area. So this is research and the results are being discussed here. Limited exposure to modern learning tools. 70% of India resides in rural area and semi-urban area where they do not have modern teaching tools. Moreover, there is a gap in teaching quality and methodology. Language and communication difficulties are being found, and we can see on the screen that IIT Kharagpur has adopted 3 language formula with stress on Bengali. It is stating that the IIT Kharagpur has a special emphasis to teach in 3 other languages, 3 different languages with local language on priority, that is Bengali. There are very few opportunities for hands-on experience, and socio-economic and motivational barriers are also been seen there. Language barrier has been found in various parts of India because we have lots of hundreds and thousands of languages which are being spoken in India, which forms a very big barrier. If we talk about if we talk about Vidarbha region, the Marathi of our Vidarbha region is different, Pune language is different, Mumbai region Marathi is different, and if we talk about Kolhapur, Solapur region, that also it has a different accent. We have different pronunciation. Some are Marathi speakers, some are Hindi speakers, some are English speakers. What happens? They do not have a proper understanding because the upbringing or learning is being done in, say, Marathi or Hindi or English and so on. So which makes a but obvious barrier in understanding or grasping the point that are being taught by the faculty. So these are language barriers are being found, and also a motivation or barrier are found. If we are talking about Akola region, so in Akola region, which type of students we have? We have lots of different students. Like some students I have completed polytechnic. Even in polytechnic also, some if we are talking about, say, BTech IT, then the student can be from a polytechnic of say CSC or IT or instrumentation. So different types of polytechnic students can go for any kind of degree course also. Moreover, some students are from 12th background or completed 11th, 12th. So they have different kind of understanding about subjects. Moving forward, some are from rural area, some are from urban area, or some are from semi-English medium or Marathi medium or English medium. All these students, all these types of 10-15 types of student can be known very well, or very easily we can differentiate. But all these different kind of students need to be brought to some specific kind or specific level of engineer, who will be called as BE computer science or BTech computer science engineer. So it is our job, and which is a very kind of a hectic job, or which requires special skills, to bring all these varying kind of students who have different kind of understanding, learning capacity, abilities, background, barriers, to a standard bar or standard which will be calling them and which will be making them fit for job. Let us see how this scaffolding work by a small video. So if we closely observe this video, the father is teaching his son to ride a bicycle. First, he has been holding his seat, his handle, and then giving him necessary support and a push, and then letting him drive his bicycle and completely at his task. So in the same way, what is our scaffolding is all about? To give a necessary support wherever needed by the student. First, the faculty will be teaching him or her the complete numerical. Say a numerical will be completely solved by the faculty. He will be giving the guidance, he will be explaining and solving the numerical by himself, and later he will be asking the students to solve the numerical by themselves. So the support here, if we see this video again, the support was given fully in the starting and partially removed in between. First, the father leave the handle, then the seat, and then let him drove his bicycle. Step by step, the support has been removed by his father, so that the son will be driving his bicycle by his own self. So the success goes step by step, as the person here is going one step at a time. In the same way, one step at a time, support system is removed one step at a time, so that the student will be going towards his or her success of understanding the any kind of concept. In the same way, from site scaffolding to a classroom scaffolding. Now, if we talk about the site scaffolding, that is on our construction side, it is a external structure, it is a temporary structure. It allows safe work site at height. When we are at a height, the scaffolding, what we call the scaffolding, it can give it is a temporary structure, and it is a external structure. It is not a part of any structure, but as a temporary structure. It is just a support system which is being used for some days, so to construct a permanent structure. In the same way, when we are talking about the classroom scaffolding, it is structured guidance, it is temporary guidance, it allows safe workspace to achieve the higher cognitive levels. What are these cognitive levels? They are the Bloom's taxonomy levels. In the era of NAC, NBA, autonomy, deemed universities, we are all well versed with these terminologies, the Bloom's taxonomy. So what is the instructional scaffolding talks about? It is a structured guidance given by the faculty. It is temporary, it is for time being, so that the permanent impact of higher cognitive level will be achieved by the students, that is remembering, then understanding, then he will be trying to apply it. He will be analyzing what has been done, how he has used. He will be evaluating how better the work can be done, and then he will be creating the best version possible. So at the different levels of cognitive levels, to achieve higher cognitive level, we will be supporting our students step by step, and a structured guidance will be given as required at that time. Obviously, the guidance level at the higher cognitive level will be of different kind, and to some extent we can say in generalize it will be just a guidance or just a watch or just a support exterior. It will be just a channelizing kind of thing, so that the student himself will be able to create or solve or apply the concept what we are teaching in the class. Here the emphasis is that both are planned way, both are planned before the class, they are to bear the load, and the support is removed only when the main structure, that is student competency, is stable. The student, whenever the student will be showing the competency what is expected for that class, for that session, for that practical, then the support is being removed step by step in a gradual way. So what are the techniques for scaffolding? Basically, it is our faculty's duty to understand what kind of student we are teaching or what kind of background the students are coming from. Like talking about semi-urban area or rural area like Akola region, Amravati region, we have students generally completed 12th standard, opting for CET, then or they will be opting for diploma and then coming for direct second year also. So they all the students will be have different understanding, different skills, different barriers, different languages, different scores in the CET or JEE and so on. So all these students' background should be understood, known to our fraternity. We should be using visual aids like diagrams, flowcharts, stage models, videos, simulations and so on, so that they will be well acquainted with what exactly it is going on, not just direct instructional method or not just giving lectures. We should be questioning and think aloud to model reasoning step. We should be questioning after some equal amount of time. We should be giving hints, prompts, checklists, partially completed templates, so that they will be thinking about what the teaching is all about, what the topic is all going on in the class. And formative assessment throughout the session, the formative assessment and feedback should be given as per the level of teaching or level of the student is there. So the strategy here we need to opt is I do, we do and you do. I do means the teacher will be doing, we do means teacher and the student will be doing, the instructor and the students will be doing. You do means the students will be doing by their own self. So I do, what comes in I do, the teacher will be demonstrating the question or the numerical and giving the numerical in the class, telling about the background and giving the numerical and solving the numerical on the blackboard wholeheartedly and on his own self. There is no intervention of students. Then for the next numerical, we do, that is the teacher will be giving the numerical, giving the background, asking the students to solve to some extent, and when they will be stopping or having some hurdle, he will be asking, is it solved, is it not solved, what is the query and so on, and he will be solving the numerical for a less quantity of time or less in a lesser way. He will be asking the student to do it for some part of the numerical also. Just the tricky part will be done by the faculty. Then the you do point. At this stage of you do, what the faculty has to do, the faculty has to give the numerical to the students, and the students will be solving the numerical by their own self. which will be fortifying them to opt for the semester end sem exams, and also to complete the say kind of the project or that model or that program. So for example, if I have to teach fire safety principle and emergency response in my class, what I will be doing, I means the teacher, what I will be doing as a teacher, I will be explaining what is fire, what is the concept of fire, requirements of fire, why it is not good in the building, what are the emergency measures that can be done, how to fight with the fire. So the classic example is the PASS, PASS, that is pull the nozzle of that fire extinguisher, aim toward the fire, squeeze the handle of the fire extinguisher, and sweep, that is to spray the gases, chemicals or water on the fire. So this is the theoretical background what I will be telling from A to Z, that is from starting to end. I will be giving all the theoretical aspects of my understanding. Even I will be showing some pamphlets or the actual fire extinguisher also. Then what will be the second step? It will be the guided practice, that is we do. I will be giving them say evacuation plan, a template for a group of people, and ask them to explain or explore the fire extinguisher by themselves, and let them handle to some extent that fire extinguisher. Later, independent practice, that is you do. I will be asking the student to do the fire drill, mock drill, or prepare a chart for the fire extinguishing system or fire safety system for the said building, or ask them to handle the fire extinguisher for themselves. That is actually they will be doing it. So how it started? Like it started with the basics of the fire extinguisher, starting from actual definition of fire, requirement of fire, that is H2O is oxygen is needed, O2 is needed, and so on. Very basic things were explained first. Actual apparatus were shown, pamphlets were shown. Then I asked the student to come with me, handle the machine, to try to do the work, try to develop a mock drill, and so on. Then in the later stage, what I did, I asked the student themselves to develop a mock drill, develop a evacuation chart, develop a fire safety plan, or actually use the fire extinguishers or the hydrants, and so on. So we are gradually increasing the ability, the learning outcome, the learning level is being increased step by step, and the guidance is being reduced. The intervention by the faculty in his or her learning is reduced step by step gradually, so that the student will be doing the mock drill or that item by himself or herself. So this is what we actually want, that the student should be doing the work by himself, be strong enough, fit enough, have understanding enough, so that he will be doing the work by himself, obviously in the supervision of the faculty. During this process, assessment and feedback as scaffolds needs to be done. How to do the assessment of the students? Like taking small quizzes during the class or after the class, muddiest point cards, that is we will be asking the students to tell that what were the items or what were the concept which made you think a lot, or which is not being understood very well, that is which is their respective weak zones, so that they will be telling us, and we will be working on the specific points, completing the understanding. And exit tickets, that is how you felt, and the result will be disclosed and will be given support as needed. Obviously student to student it will be varying, that is all the students will be given due attention, no one will be left behind. It will provide timely and specific feedback. Small hints will be given instead of full answers, so student will do the heavy cognitive work. Only guidance will be given, feedback will be given, direction will be given, but actual work will be done by the student. Later, what are the common mistakes in scaffolding? First is over scaffolding, that is, a lot of hints will be given, or if we want a student to solve a program, then we will be giving the directly solved program. Okay, say Ramamrutam textbook is there, solve numerical, I have taken a numerical, now you solve this solved numerical at home. How we can expect that the student will be doing this solved numerical? It may be the case that he will be looking into the solved numerical readily available in the textbook. So it will be a kind of over scaffolding. We should be giving them a numerical, and at max should provide the final answer. It is acceptable. But if we are giving directly solved example, then it will be over scaffolding or over supportive, which is not good and not expected here. Students will be becoming more dependent and cannot tackle novel or similar kind of problems. Under scaffolding. Here, under scaffolding means what? The jumping directly to the complex numerical. That is, we will be not explaining the concept, but directly jumping on the numerical. I have given you the theory and you solve the numerical. It is not expected here. Or one size fits all. That is, we have earlier seen that for engineering fraternity we have varying kind of students and varying kind of understanding, which cannot, so all the students cannot have same psychology or same understanding or same thought process, same content delivery cannot be done. Scaffolding cannot be given. So we need to be, as a faculty, we need to be very cautious and kind of fragile, so that we will be opting the scaffolding concept as per the student, person to person, student to student. Scaffolding should be adopted. So I would like you to deliver me the topic or share your thoughts on your topic on the basis of I do, we do and you do. Doing this activity, I will be appreciating if you share your thoughts in the chat box and in the group also, so that we will be discussing it later, like what will be your I do, we do and you do for a set topic, which will be helpful for your developing your lesson plan. So in the recap, what are the key takeaways? The three key takeaways are: scaffolding is what? It is giving students a temporary and planned help based on what they know, then slowly taking that help away as they learn more. Step by step removal of the support we are giving to our student, so that he will be gradually doing the work, solving the numerical, drafting the program by himself. In engineering, scaffolding breaks tough problems into smaller, doable steps, helping students gain confidence and think like professionals. It will be not only exploring or developing their problem solving ability, not only making them fit for end-sem exams, but it will be developing their cognitive level, their understanding, and making them a more fit and fine professional, which will be developing their aptitude against that subject, against that topic, which will be having a very, very good impact for their learning and developing them a very good engineer. Third is that simple actions like showing examples, breaking tasks down, giving checklist, gradually reducing support can make a big difference in learning without needing extra tools or resources. Like when we give them examples or divide the activities or that problem into number of tasks, it helps the student to follow that checklist or that path by reducing a kind of fuss or some discomfort for the student and leading them to the successful completion of the topic, model, or so any item they are doing. making the work easy, and that does not need any extra tools or resources. So this was all about myself on the topic of scaffolding. I will really appreciate your queries, and also I would like to hear suggestions from you all about this scaffolding concept, so that we would be doing some innovative work or improve our learnings. So finally, I am thankful to the organizing team of the civil engineering department for this wonderful STTP, organizing this wonderful 4-week STTP on pedagogical teaching methodologies, which is obviously the need of time. Once again, thankful to the society, to the college, to the department organizing team for giving this opportunity to share my understanding about scaffolding. So thank you one and all. Thank you.